See, once let us revise few points. Anode is negative, cathode is positive, both are connected by a salt bridge, this half cell and this half cell. Okay, and here one ammeter is arranged to measure the current, right? Anode is negative, cathode is positive. This is having one electrolytic solution, zinc sulfate. This is having another electrolytic solution, copper sulfate. Clear? At anode always oxidation takes place, at cathode always reduction takes place, right? What is the movement of electrons? Electrons will move from anode to cathode, current moves from cathode to anode. Okay, the reaction is same in electrolytic cell. At anode oxidation takes place, at cathode reduction takes place. Here also same, but the difference is signs. Anode sign and cathode sign is different. It is having two half cells, okay, separate half cells, but in electrolytic cell only in one cell two rods are immersed. Here rods are immersed in the separate cells. Minor differences are there. Okay, and one important major difference, you tell me in electrolytic cell how energy conversion takes place. Energy conversion, which energy converts into which energy in electrolytic cell? Electrical to chemical. Here chemical energy to electrical energy. When chemical reaction takes place, current will generate. So chemical energy to electrical energy, right? Right. Now let us start new topic, electrode potential. Electrode potential, okay, oxidation potential, reduction potential, E cell, EMF of this cell, and Nernst equation. Previously, recently, May 3rd exam was over now in the May month, this month, right? Question came on this Nernst equation, simple question, very simple question. Okay, right. So sometimes we'll get easy questions. This time from electrochemistry, very easy question came. Clear? And that is second part actually. See, we did first part, right? In first part, what we did? Conductance, equivalent conductance, molar conductance, Faraday's laws, everything with electrolysis. But the question didn't come from that first part. Question came from the second part. So sometimes from first part, sometimes from second part, like that. Or sometimes at the end, fuel cells, like that. Okay, we cannot say, but you should thorough from starting to ending every topic, every concept. Right. Electrode potential. See, understanding terminology is very important in this. Little bit imagination only, related to physics also. Understanding the terminology is very important. Clear? Imagination. Right. To understand this term electrode potential, I'll tell you one small thing to you. Just a second, someone are giving message, I think from my college. Oh, right. See, already we did electrochemistry in the first year, right? Few students listened. Adiba, correct or am I correct? Have I taught electrochemistry to you? Complete electrochemistry, Adiba? Okay, right. Okay, no problem. Now again we will discuss, no issue. See, to understand terminology, you have to remember some points throughout this topic, electrode potential, Nernst equation. You consider positive charge area, high potential. Don't go beyond this word, okay, right? Again, don't ask what is high potential. High potential means again I have to enter into physics, okay? Energy per unit charge. Potential means energy per unit charge. So what I am saying, to understand this topic in easiest way, just you remember, high potential means more positive charge area. Low potential means negative charge area. Low potential. high energy, low energy. Potential means energy per unit area. Actually this I don't want to give, but I am giving. Potential means energy per unit charge. Energy per unit charge. Okay. See, the bad thing is others wrote different books, right? But there is no perfect definition for electrode potential. There is no satisfactory definitions also. Clear? Exact definition is not given. They given some definitions, but that are not suitable to explain by the students. So just I am trying with simple words and terminology. I hope you will understand. Clear? So to understand this electrode potential, first you should know high potential, low potential words. High potential means in that area more positive charged particles are present or more positive charge is present. Clear? Low potential means negative charge is present. Clear? Again, potential means energy per unit charge. Clear? Potential means energy per unit charge. I am giving these terms by my own. Clear? You can follow this or in the numericals. While doing numericals, no definition will helpful for us. Okay, we can do very easily. Numerical part is very easy, but understanding the terminology only the difficult thing. Clear? So if you understand 50-50, then also no need to worry. Clear? You can do the numerical. Everyone can solve the numerical part, right? Numerical part is very easy, right? Okay, we completed high potential and low potential. High potential means more positive charge. Low potential means more negative charge. Right? Now I am asking you one question. High potential. Just I am taking one value, high value, and low value. Numbers I am taking 104. Difference is there or not between 100 and 4? By seeing this, we can think that this is a bigger value. This is a smaller value. Bigger, smaller means there only difference is there. Yes or no? You only saying now bigger value, high number and low number means you are indirectly saying difference. So when you see 104, indirectly you are saying the difference. Correct only na? Higher value, lower value. Higher, lower means you are differentiating them. You are saying difference is there. What difference? Value. Clear? Similarly, when you observe positive charge beside negative charge, their difference will be there. When we see higher and lower, like this, higher and lower, there is a difference. What is the difference? Potential. Potential means energy. Got it? So whenever you observe positive charge and negative charge side by side, there exists a potential difference. Similar case, when you see higher value, lower value, difference will be there. There exists a difference. Oh, what is the difference here? General I am asking. 96. Difference is there or not? So whenever you observe positive charge beside negative charge, between them difference is there. Energy difference, because potential means energy. No? Remember this point. To understand this term, electrode potential, to understand this term, you have to remember this. Got it all of you? Now you tell me. Don't see the board, look at me, tell me. What is high potential? High potential means which charge? Tell me. High potential means positive. Low potential means negative. So when you observe positive charge and negative charge side by side, difference will be there or not? Positive means higher energy, negative means lower energy. So difference will be there, right? So the difference is potential difference. Clear? Now let us start electrode potential. This simple discussion will help us to understand the term electrode potential. Okay? All of you. Let us start the definition. Boys, are you getting? Hello boys. Srujan, are you there? Boys are there or not? Electrode potential. Take zinc sulfate solution in a beaker, ZnSO4. Zinc sulfate. In this Zn plus 2 ions are present and SO4 minus 2 ions are present. Okay. In equal amounts. If 100 zinc plus 2 ions are present, then 100 SO4 minus 2 ions are present. Right? This is the solution. Zinc sulfate solution. Right? In that positive and negative ions are present. Okay. Now, place zinc rod in this. Place zinc rod. When we place the zinc rod, surface zinc atoms converted into ions, zinc ions, and released into the solution, Zn plus 2. Okay, you cannot survive, this will happen. That is the tendency of zinc metal. Zinc is having tendency to lose electrons easily. Okay, surface zinc atoms converted into Zn plus 2 and enter into the solution like this. Zn plus 2 ions will be released. You have to remember like that only, clear? If you wanted to extend, there is infinite. Okay, again one new term will come, to understand that again you have to know another new term. So simple, just stop. Limited explanations. Okay, satisfactory answers are very important in that. Okay, if we wanted to extend, then we can, then new words, clear? So what you have to remember, when you place the zinc rod in zinc sulfate solution, surface zinc atoms converted into Zn plus 2 and enter into the solution, right? Leaving negative charge on the surface. What is the meaning of leaving negative charge? See, when zinc undergoes oxidation, what happens? Zn plus 2 electrons. Zinc release Zn plus 2 and then electrons, right? So Zn plus 2 ions are entering into the solution. What about electrons? Electrons retained on the rod only. So I am representing electrons like this. Negative. Okay. On the rod, the negative charge will be accumulated. And into the solution, positive charge is releasing. Means Zn plus 2 ions are releasing. Electrons are remains on the rod only. Clear? Now, on the rod negative charge is present. In the solution, which charge is increasing? Before immersing the rod, Zn plus 2 ions are there, SO4 minus 2 ions are there in equal amounts. Electrical neutrality is present. Before immersing the rod. After immersing the rod into the solution, extra positive ions are coming, right? Additional positive charge is coming. Positive ions are coming. Positive. Due to Zn plus 2. Positive. Now take out this picture, this side. Negative. Positive. You can observe this picture when you immerse the zinc rod in zinc sulfate solution. Once go back to the previous slide. What I explained, when you observe positive and negative side by side, then what happens? Potential difference will be developed. Yes or no? I explained this concept to understand this, right? So when you observe positive and negative side by side, there exists a difference that is called a potential difference. Now look at this picture. Positive and negative side by side. So between them, difference will be developed. Potential difference will be developed. Negative and positive, potential difference will be developed. Clear? That is only electrode potential. The potential difference developed at the junction of electrode and liquid electrolytic solution. Liquid means electrolytic solution is called as electrode potential. The potential difference developed at the junction. Junction means this area. Okay. And the contact place, liquid and electrode contact place is called a junction. Okay. The potential difference developed at the junction of the metal or electrode and electrolytic solution is called as electrode potential. Positive charge and adjacently negative charge is present. Positive, negative, electrical double layer. Okay, due to that difference will be developed. This case actually, positive charge means higher value. Okay, high potential. Negative charge means low potential. High low means difference will be developed. Difference is there. For example, if I give like this, in this case, is there any difference? Is there any difference developed here? No, because 100 and 100. Then how can you talk about difference? You cannot talk about difference. Clear? If you have high value and if you have low value, then you can talk about the difference. Clear? High potential, positive charge. Low potential, negative charge. High and low, so difference is there. Potential difference. Clear? I already said to you, understanding the terminology is important. Okay? Better to follow with limited explanation. So you tell me, what is the electrode potential? Anybody? What is electrode potential? Tell me the potential difference developed at the junction of the electrode and electrolytic solution is called as electrode potential. Any doubt in this? Please tell me. Learn this definition and leave it. Don't do the research. Okay, this is a infinite topic. This is sufficient. This definition, you want definition in the PDF? I'll send the definitions are there in the PDF. How I am explaining in similar case are given with a beautiful explanation and diagrams. Clear? You will get easily. If you listen to this and if you read that PDF, you will get easily. How I am explaining, I given in the simple terminology only. You can understand easily. No need to worry. Right? Okay. You answer this question, all of you. What I did here? What I did? I placed the zinc rod in zinc sulfate solution, right? Then what happened? Zinc is converting into Zn+2 and releasing into the solution, and electrons are accumulated on the rod only. Right? See, due to this reaction, potential difference is developed. Yes or no? Due to this reaction means, tell me, this is which reaction? Oxidation reaction or reduction reaction? Losing the electrons is called oxidation reaction. Why? Because zinc is losing electrons. This is oxidation. Potential difference developed due to oxidation is called as oxidation potential. This reaction is oxidation reaction. Potential difference developed due to oxidation process. This is oxidation process. Loss of electrons is oxidation. Is called as oxidation potential. Clear? See, second part is easy only, but where we feel difficulty in the terminology. So what is my best suggestion? Term and definition, close it. Term and definition, close it. Don't enter into the depth. For numerical part, what is required, I'll give you. Everything I'll give you. But don't do the research on the terminology. You know electrode potential. Extend that. Electrode potential. Again classified into two types, oxidation potential and reduction potential. You know definition of electrode potential. Divide it into two types, oxidation potential and reduction potential. Oxidation potential means potential difference developed due to oxidation reaction or due to loss of electrons by the metal. Potential difference developed due to oxidation reaction or due to loss of electrons by the metal. Close it. Clear? Right. Next. Look at this reaction. Cu+2. plus 2 electrons gives rise to Cu. This is reduction reaction. Reduction reaction. If potential difference is developed due to reduction reaction or due to gain of electrons, is called as redox potential. Oxidation potential and reduction potential. Potential difference developed due to gain of electrons or due to reduction reactions is called as reduction potential. So oxidation potential and reduction potentials. Positive negative charge development due to reduction reaction is called as reduction potential. Positive negative charges development means electrode potential development due to oxidation reaction is called as oxidation potential. Right? Look at this, all of you. Electrode potential. Electrode potential. Electrode potential means, imagine this diagram. Potential difference developed at the junction of the electrode. Right? Keep this picture in your mind. This is classified into 2 times. Oxidation potential and reduction potential. I given same definition, no need to worry. Okay. What I am explaining, I given like that only. You can follow. In simple terminology, I given the definitions. Second part is important. Okay, so better to read formulas, concepts, everything. We will do numericals after completion of organic. Right? Okay, oxidation potential. See the symbol for oxidation potential, E. E represent electrode potential, capital E. OX means oxidation potential. Potential difference developed due to oxidation reaction. E reduction, RED. Or we can take it as ER also. In different books, representation is different way. You can go like this: E oxidation and E reduction. Okay. Now, standard oxidation potential. Standard oxidation potential. Oxidation potential measured or oxidation potential developed at standard conditions. For example, look at this. That is first example only. I am taking zinc sulfate, ZnSO4. Okay. I am placing zinc radar. Then what happens? Oxidation takes place, right? Zinc loses electrons, Zn plus 2 electrons. Oxidation reaction takes place. And on the rod, negative charge is present. In the solution, positive is present. Positive, negative. Whenever we observe positive, negative, there exists a difference. Higher value, lower value. Positive means higher value, negative means lower value. So difference exists. Potential difference exists. Right. Now, what you are doing, you are placing the zinc rod in zinc sulfate solution, right? Do this experiment by maintaining standard conditions. Do the same experiment. Immerse the zinc rod in zinc sulfate solution, okay? But do at standard conditions. Look at this. 1 molar. 1 molar. Maintain concentration of the zinc sulfate solution is 1 molar. Standard condition, 1 molar concentration. And maintain temperature. Means, for example, you are doing this experiment in this room. So maintain the room temperature as 25 degrees centigrade. Standard conditions, 25 degrees and 1 molar. Then potential difference is developed. That is called as standard potential difference due to oxidation and standard oxidation potential. Okay. If potential difference developed at standard conditions, at temperature and concentration, that is called as standard oxidation potential. If oxidation potential developed due to standard conditions, that is called as standard oxidation potential. Very simple thing, just maintain standard conditions and call potential difference developed as standard potential difference. Very simple. Clear? This is represented as E naught generally throughout our numerical. E naught generally E and E here E just normal at any conditions, not at standard. This E represent at any condition other than the standard. Clear? For example, not at 25 degrees centigrade or 50 degrees centigrade or something 15, any value. Not at 1 molar. This E represent not at 1 molar, any 0.1 molar, 0.01 molar, like that. E and E naught. E naught means E and E naught, the terms are same only, electrode potentials only, but standard condition is different. Clear? Right. Symbol for this standard oxidation potential, E naught. E naught. E naught OX, standard oxidation potential. It is also called as SOP, standard oxidation potential, like this. E naught OX are SOP, standard oxidation potential. Standard oxidation potential. Clear? E naught. Now onwards remember, E naught means potential difference developed at standard conditions. Standard condition. Electrode potential developed at standard conditions, or potential developed at standard conditions. E naught, okay, that is OX or RED, that depends upon the given diagram. Clear? Next. So I given the definition, standard oxidation potential means oxidation potential developed at standard conditions. Over. Oxidation potential developed at standard conditions. Next. Reduction potential. Standard reduction potential. Standard reduction potential. E naught RED reduction or ESRP. Standard reduction potential values. The reduction potential developed at standard conditions. Is called as standard reduction potential. For example, I am connecting this electrode to negative terminal of the battery. Then this electrode is coated with electrons. Okay. Why this rod is connected to negative terminal of the battery? And I am taking copper sulfate solution, Cu plus 2 and SO4 minus 2. Then what happens in this case? Reduction takes place. Copper ions reaches this rod. Copper ions reaches the rod, because on the rod negative charge is there, electrons are there. So copper means all positive ions will accumulate on this. All positive ions accumulate or reach near that negative charge. Again positive, negative. Difference is there or not? Clear? Cu plus 2 plus 2 electrons gives rise to Cu. This is reduction. Reduction potential developed at standard conditions. Maintain this electrolytic solution concentration as 1 molar, temperature 25 degrees centigrade. Reduction potential developed. This is reduction only. Copper plus 2 ions are reaching the electrode to accept electrons. Reduction. Okay, but we are doing at standard condition. This experiment at standard condition, placing the rod in copper sulfate solution at standard conditions. Okay. So reduction potential developed at standard conditions. 1 molar electrolytic concentration, 25 degrees room temperature, at the cell temperature. Then that is called as standard reduction potential. E naught RED or SRP. SRP, standard reduction potential values. Generally, we prefer to take SRP values during the numerical part. And yesterday's means this third question came, that is also depends on the SRP value, reduction potential values. Okay, because most of the metals ready to lose the electrons. zinc, sodium, magnesium, iron, aluminum. All these ready to lose the electron. So we have so many metals with reducing property. That's why reduction potential values are preferred during numerical part. Majority of the metals like zinc, iron, manganese, magnesium, all these are reducing agents. That's why we prefer SRP values for the numericals. Clear? Right. I hope you understood this terminology. Right. Next, another term, E cell. EMF, E cell or EMF or electromotive force. Electromotive force. Electromotive force. E cell. EMF, electromotive force, E cell, all are same. Okay, this is just abbreviation. Okay. Let us take two half cells. Are you listening, all of you? I am not asking today. Are you there? I am only teaching myself. Are you there, all of you? Bhakti, Keshavarma, Adiba, Meenakshi, respond. Aisha, Srujan, what about you? Srujan, Surabhi. Yeah. Are you getting, all of you? Adiba, are you getting the definitions? Any doubt in the terminology? Meenakshi, Bhakti, Surabhi, any doubt in the terminology? Just open the PDF, learn the definitions only. Don't do the research on it because it is a time killing. If you wanted to do the research in NCERT, you cannot understand single definition also. Clear? So follow the PDF, learn the simple definition and do the numericals. Clear? See, next E cell, EMF, electromotive force. All are same terms only. Let us consider an electrochemical cell. This is an electrochemical cell. This is anode negatively charged, cathode positively charged. Okay, simple definition for E cell. You tell me, each half cell is having some electrode potential. Here electrode potential is developed or not? The potential difference developed at electrode is called electrode potential. When you place this anode rod, okay, some reactions takes place, positive negative charges exist side by side. Correct? And just now we did separately. Look at this. Where I given that example, the zinc rod, zinc anode place, and I give an example for copper also. Okay, means this is the right side half cell. This one is left side half cell. Left side half cell and right side half cell. But in two half cells we have seen the development of positive negative charges side by side. Electrode potential is developed. So anode is having some potential, cathode is having some potential difference. Clear? The sum of these electrode potentials is called as E cell. Add the electrode potentials of these two half cells. That is called as electrode potentials. See the definition. The sum of the electrode potentials of two half cells is called as E cell or EMF. E cell or EMF. Okay. Now, E cell is equal to, see, at anode which reaction takes place? At anode, oxidation or reduction? Oxidation potential at anode plus at this reduction potential at the cathode. Reduction potential at the cathode. Some we are adding. Okay, oxidation potential of anode, reduction potential of cathode. The sum of the potentials is called as EMF of the cell. Anode potential, cathode potential. Potential developed at anode plus potential developed at the cathode. Potential nothing but difference developed. Difference developed. For example, I'll give you another simple explanation to me. Negative, 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 positive, positive. Clear? Let us consider one positive value as some 10, the negative value as some 4. What is the difference? What is the difference? 10 minus 4. 10 minus 4 is equal to 6. Okay. In this case, negative, negative, negative. Approximate, just randomly I am giving. Here some 6 and some 2 are okay. 6 minus 2, 4. This difference, here some difference, that is called as EC. Okay, got it? Otherwise you just go through the definition. Discussing the definitions only tougher, but doing numericals is dead easy, very easy. Okay, after that, after few numericals you will feel that array these definitions are very easy, right? Okay, E cell is the sum of the electrode potentials of the two half cells, right? Now what about E naught cell? E naught means standard. SOP, standard oxidation potential of anode plus standard reduction potential of cathode. Any doubt in this? E naught, just we are considering standard states. Okay. Now I'm giving one relation, sorry. I'm giving one relation to you. SOP, standard oxidation potential of anode, is equal to minus SRP. Opposite terms, opposite. SOP of anode is equal to minus SRP of cathode. Okay. This won't change. Okay, at anode only we have to discuss. Just we have to change this SOP SR. For example, take one anode whose oxidation potential value is, for example, some 2.4 volt. This is the anode rod, whose SOP, oxidation potential value, is 2.4. If you put a negative, this is anode only, but you have to call it as a reduction potential, opposite sign. Anode, this won't change, this value, SOP, this term SOP minus SR. Okay, now apply this here. E naught cell is equal to, tell me, SOP of anode is equal to, tell me, SOP of anode is equal to minus SRP of anode plus SRP of cathode. This is the important formula. Okay, very important. Now let us rewrite this. Just write positive first and negative last. E naught cell is equal to, I am writing this first, SRP of cathode minus SRP of anode. So this is a frequently used formula. By heart it now only by heart it. E naught cell is equal to SRP of cathode minus SRP of anode. E naught cell is equal to SRP of cathode minus SRP of anode by heart it. Clear? This is the main formula. Right? All of you. Shall we go to next topic? All of you. Electrochemical series. Electrochemical series. You know spectrochemical series? How many of you can say the order? Ligands order. I given the codes also in complex compounds. Ligands, strong field, weak field ligands. Code I given iron brother 8 solid. With Sinchan, with fun at night time. Donated food for ox, food and water for ox, and went to American pyramid. After that visited California, Colombo. See, everyone listen to my words. Are you listening? All of you say yes. I'll tell you one important point to you. Are you listening, everybody? Are you listening or not? All of you. No one is answering. Frequent revisions are very, very important. See, the most the problem students will say, the NEET students at the end of the academic year, sir, I have to read this chapter, I have to read that chapter, I am forgetting the formulas, I am unable to do the numericals. Actually, these things will happen. What is the reason? Main reason due to lack of revisions. Actually, complex compounds over, right? Complex compounds is over. But you tell me how many of you read 1 week back or 4 days back? How many of you read? How many of you checked yourself that ligands information, formulas, EAN rule? Clear? This is very, very important. NEET questions are very easy. But the third paper, you people can attempt all the questions, no doubt in that. But you should have spontaneity on each and every yes. Clear? Frequent revisions are very, very important. Nobody will say to you to read this chapter, that chapter, by this time, by that time. You have to make your own plan, but don't give the gap more, means 10 days gap. Within the 10 days only, every lesson should be revised. There is a continuous process. Clear? Irrespective of your college syllabus. This is actually I wanted to say you at the beginning of the classes only. Remember now, clear? Irrespective of your college schedule or anything, you have to read all the lessons. Like first year also. Okay, first year physical chemistry, inorganic, organic. Okay. Frequent revisions are very, very important, right? Otherwise, you will feel hectic at the end. Electrochemical series. See, like a spectrochemical series in the complex compounds, electrochemical series. Electrochemical series, it is the series of electrodes. Series of electrodes which are arranged in the increasing order of their reduction potential values. Series of electrodes, series, the order, okay, with increasing order of their electrode potential, increasing order, negative to 0 and positive, increasing order, negative, 0, positive. I'll give a few examples. Just tell me. For more 5 minutes only. Yeah. More 5 minutes. 7:15 actually. I started 6:15. Now. More 5 minutes. Yeah. Good evening. కిందనే కూర్చోండి, నేను కిందకు వస్తాను. ఆన్లైన్
ఆయన ఫోన్ చేశాను కానీ బిజీ. ఆయన ఉస్మాన్లో
పర్లేదు
ప్రొఫెషన్లో ఆయన ఫార్మర్ సార్. जी ओके ओके ओके, मंडे के बाद ही जब भी आपको आओ।
अभी निकला मैं सर, मीटिंग को चला था।
ओके ओके, कभी भी आपको मंडे के बाद कभी भी आ जाइए, वो फोन कर लीजिए।
పర్లేదు ఏం నేను వచ్చినప్పుడు
ఇప్పుడు మనం ఆయన మనకు కాల్ చేశాడు, ఇప్పుడు నేను
అదే లేదు లేదు పాపం
సరే బిజీ ఉన్నాడు ఆయన, ఎందుకంటే ఇంకా పెద్ద ఆయన నేను ఏం చెప్పలేదు.
పర్లేదు నో ప్రాబ్లం.
మనం ఏం చేద్దాం, మండే తర్వాత ఆయన ఫోన్ చేసినప్పుడు రాదు.
నేను ఒక 5 నిమిషాలు వస్తానని చెప్పండి, క్లాస్ అయిపోయాను. ఓకే. Correct. Lithium minus 3.0 volt. Zinc minus 0.74 volt. Hydrogen. It is a reference electrode. Actually, I'll explain tomorrow. 0 volt. Hydrogen is a reference. Primary, standard. Copper, its value is plus 3.6. So approximate values, these are not exact values. Look at this, just you observe minus to 0, 0 to positive, observe that only. Clear? You no need to learn the values will be given to you. Fluorine, non-metal electrode, its value is plus 2.17, something like that. Okay, on the 2 on that we no need to by heart the values. Clear? See, you will get the values in the question, no need to by hand, because so many metals are there, they won't ask about values every time. Minus to 0, 0 to plus. So it is a electrochemical series. It is a series of electrodes which are arranged in the increasing order of their SRP values. This is SRP, actually standard reduction potential values, SRP values. This value is SRP, standard reduction potential values. Series of electrodes which are arranged in the increasing order of their SRP. Okay, and we will discuss applications of this electrochemical series tomorrow and an next equation. Within half an hour we can complete. Clear? Applications of electrochemical series we will discuss tomorrow. That is very important class, don't miss. Clear, all of you? Any doubts, girls? Any doubts? Shall I close this?